Okay, from our previous discussions, tipanga develop circuit ya suspended insulator. We are saying the suspended insulator, insulator which are represented by capacitance. So you have that capacitor for insulator 1, capacitor for insulator 2, capacitor, insulator 3, capacitor, insulator 4, and this is what we call these capacitances, what we call mutual capacitances, because the properties of the insulators are the same, so the capacitance is also the same. So here it's where our conductor is. Yeah, so that's that. Sorry, on this one we have our capacitance, that's shunt capacitor, and also have a shunt capacitor here, another shunt capacitor, and another shunt capacitor there. These shunt capacitances are also equal because this string is parallel to the pole. This is a pole, that's a cross arm. So label them as C1. Yes. So on this one, we are saying there's a conductor here. So current will flow in this manner. Current will flow in this manner. Yeah. So we're going to label current as I1 there. Here, I2, I3, I4. And we have that I1 small letter, I2 small letter, I3 small letter, and I4. And there's a potential difference. Yeah, from V1, that's from cross arm to the first disk, and the second disk there's another voltage which is V2, and there another voltage which is V3, and there another voltage which is V4. Yeah, that's that. So the idea is to find the efficiency of our insulators. So that efficiency is found by as that's total voltage. That's total voltage V1 plus V2 plus V3 plus V4 divided by number of insulators N times the lowermost voltage, the voltage which is close to the conductor. So that's a V4. So our duty is to find the values of these voltages in accordance with the capacitances and the currents. So for a start, we let C1 over C to be equal to K. K is a constant, it's just the ratio of shunt capacitance to mutual capacitance. And so this will be C1 as C. Okay, that's that. From here, we find V1. So V1, no, not V1. We want to find V1, but for us to find that V1, let's use this node to find those currencies. We say I2 will be equal to, I think it's Kirchhoff current law. I2 will be equal to I1 plus I1. And we also know that voltage, it's equal to IR. In our scenario, it will be equal to IXC, which means current from there will be equal to V over XC. Yeah, like that. Therefore, yeah, but we also know that XC is equal to 1 over 2 pi F C. Yeah, but this can be written as omega, because 2 pi F is equal to omega, which means that one is as good as to write like that, which means that I will be equal to V over XC, which is 1 over omega C, which is equal to V omega C. Yes, like that. And we substitute this into that equation. So we have I2, which is V2 omega C. These are constants. We should be able to I1, and this one is this kind is for the shunt capacitance. So it will be WC1 V1, okay, plus WC V1, like that. But this one, we have found that is C1 is equal to CK, so we can replace it here. Then we have V2 omega C, which is equal to omega CK V1 plus omega C V1. So the omega C have been taken out, so we'll remain with V2, which is equal to K V1 plus V1. Therefore, V2 will be equal to V1 1 plus K. Yeah, so that's V2. That's V2. Then we'll proceed to the second.